This is the screencast for section 3.5, example 5. I want to talk to you about orders of magnitude first. First of all, an order of magnitude is a common logarithm of positive quantity. Now, if you remember, logs find exponents, so a common log is a power of 10. So in other words, an order of magnitude is 10 to the somethingth power. For example, orders of magnitude can be used to compare any like quantities. So a kilometer is 3 orders of magnitude longer than a meter. So in other words, 1,000 meters is a kilometer. A kilometer is 1,000 times longer than a meter is. A dollar is 2 orders of magnitude greater than a penny. So a dollar is 100 times bigger than a penny, 10 to the second times bigger. A horse weighing 400 kilograms is 4 orders of magnitude, so a 1 with 4 zeros, that would be 10,000 times heavier than a mouse is. New York City, with 8 million people, is 6 orders of magnitude bigger than Earmuff Junction with population 8, so it is 1,000,000 times bigger. New York City is 1,000,000 times bigger than Earmuff Junction. I actually Googled it. I Googled Earmuff Junction, and the only thing that came up, even on Google Maps, was just a bunch of math problems. So I think Earmuff Junction is a place that mathematicians make up so they can have a place with population 8. I don't know. Now, as we mentioned in exercise 52 of section 3.4, the Richter scale, magnitude R of an earthquake, is this, where A is the amplitude in micrometers of the vertical ground motion at the receiving station. T is the period of the associated seismic wave in seconds. So amplitude is kind of like the height of the wave, how tall and how low it gets. The period of the wave is how often the wave repeats itself. And then B accounts for the weakening of the seismic wave with increasing distance from the epicenter of the earthquake. So in other words, where the earthquake actually happens is going to be the strongest sensation of the earth moving, and then the farther away you go, the weaker it is. So they can account for how far away you are, lessening the intensity of the earthquake. Now, example 5 says, how many times more severe was the 2001 earthquake in Gujarat, India, which was a Richter reading of 7.9. We don't really have units for this, 7.9 Richters. I don't know, it's just a Richter scale. So how many times more severe was the 2001 earthquake in Gujarat, India than the 1999 earthquake in Athens, Greece, which was 5.9 on the Richter scale? Well, let's see. Since I know that the Richter scale reading comes from a common log, I know that this is a exponent of 10. Remember, logs find exponents, and the exponent it's finding is of base 10. So if I'm going to find how many more times severe something is of another, I really want 10 to the 7.9 divided by 10 to the 5.9. And then, so look what I'm doing with my exponents. It's 10 to the 7.9 minus 5.9, which is 10 squared. So it was 100 times more severe. That's pretty severe. It's pretty dramatic between just 2 points on the Richter scale. Now, when I think about the intensity of an earthquake, I think about, my reference is the movie Independence Day. Will Smith and his girlfriend, they're like sleeping, and the spaceships are rolling in, and Will Smith jumps out of bed. He's like, oh, is that an earthquake? And she's just like, go back to bed. It's a 4-pointer. So that 4-pointer seems pretty not intense if she's willing to go back to bed. Don't worry about that one. But a 5.9 might be a little bit more intense. 7.9, I mean, that's 100 times more severe than a 5.9, which might be even 1,000 times more severe than a 4-pointer. So you're talking in 7.9, that's a pretty intense earthquake. Now try problem number 45. It says, how many times more severe was the 1978 Mexico City earthquake than the 1994 Los Angeles earthquake. So again, how many times more severe? We're going to take 10 to the 7.9 and divide then by 10 to the 6.6, which is just subtracting their exponents. I know these Richter scale ratings are of base 10 because they come from a log base 10. And that would get us to be about, let's see, so that's 10 to the 1.3. So that's about 19.95 times more severe.